So I'm going to go over the concepts that were covered on your Module 3 quiz, and as you are completing the video, you're going to answer the questions embedded, and your score on those questions will determine the amount of points back you earn on the quiz. So the first thing we covered was knowing whether or not a relation is a polynomial. So when you're determining whether or not a relation is a polynomial, you look at the variables, okay? So a polynomial is, and a relation is not a polynomial if there are negative fractional exponents, any type of root, or a variable in the denominator of a fraction. So when looking to see whether or not a relation is a polynomial or not, we really look to see if it has any of the things that don't make it a polynomial. If it doesn't have any of these things, then we say yes, it is. So the key thing is for the variables, all of the exponents have to be positive whole numbers. So we exclude things. So any negative fractional exponents, roots that appear, or any time a variable is in the denominator of a fraction. So next we took a look at adding and subtracting polynomials. So whenever we're adding or subtracting polynomials, we're just combining like terms. Okay. The key thing here is exponents don't change. Okay. When you combine like terms here, the exponents don't change. They stay the same. So something like x squared minus 8x plus 7 plus 2x squared plus 2, we combine like terms. So x squared and 2x squared is 3x squared. There's no like term for my negative 8x, so it stays minus 8x. And then 7 plus 2 is 9. When we're subtracting polynomials, remember, I said to always distribute that negative into the second set of parentheses first. So we have 7x cubed minus 3x plus 2 minus x cubed minus 5x squared plus 2. Now it's an addition problem where we can combine like terms. So 7x cubed minus x cubed is 6x cubed. There's no like term for our x squared term, so minus 5x squared. There's no like term for our x term, so it stays minus 3x. And then 2 plus 2 is 4. Next, we're going to take a look at multiplying. So the first type of multiplying we discussed, if you're multiplying a monomial by a polynomial. So something like 4x squared times 5x squared minus x plus 9. Okay, so here when we multiply, we add our exponents, okay, and we multiply their numbers. So 4x squared times 5x squared. 4 times 5 is 20, and then x squared times x squared is x to the 4th. And then 4x squared times negative x, so it's 4 times negative 1, which is negative 4. And then x squared times x is x cubed. And then 4x squared times 9. 9 times 4 is 36. And there's nothing for the x squared to combine with, so it stays x squared. Then we did multiplying binomials by binomials. So I'm going to do 2 different examples of how this was put on the quiz. So something like our first example. x plus 6 times 3x minus 2. Everything in the first set of parentheses multiplies to everything in the second. So first I'm going to do x times 3x, which is 3x squared. Then x times negative 2, which is negative 2x. Then we multiply 6 times 3x, which is 18x, and 6 times negative 2, which is negative 12. Combining our like terms, we end up with 3x squared plus 16x minus 12. I think the most common mistake I saw on this problem was forgetting about the middle terms. A lot of people multiplied x times 3x and would do the constant times the constant, but forgot about the middle terms. Another example is something like this: 6x minus y squared. The important thing to remember here is that we have to expand this expression. So it's 6x minus y times 6x minus y, which we're now going to multiply exactly the same way we did our previous example. Everything in the first set of parentheses multiplies by everything in the second. So 6x times 6x is 36x squared. 6x times negative y is negative 6xy. And then negative y times 6x is negative 6xy. And then negative y times negative y is positive y squared. Combining our like terms, we get 36x squared minus 12xy plus y squared. There were two common mistakes I saw with something like this. The first one being that you didn't expand, so you just did 6x squared and then y squared. The second common mistake was when multiplying negative y times negative y, forgetting that it changes to a positive y squared. Because anytime you multiply two negatives, it does become positive. Next were the division problems. So the first thing I'm going to do is an example of long division. And then I'm going to do an example of synthetic division. Okay. So when we set up long division, what we're dividing by goes in front, and then what we're dividing goes underneath. Okay. So we have x squared minus 3x plus 6 divided by x plus 2. So we want to figure out, what do I have to do to x to make it an x squared? So x squared divided by x, which gives us x. So that's going to go up top. Then I want to do x times x plus 2, which becomes x squared plus 2x. And then we're going to subtract the entire thing from our polynomial. X squared minus x squared cancels. Negative 3x minus 2x becomes negative 5x. And we're going to bring down our positive 6. Now I'm going to repeat the process. Negative 5x divided by x is negative 5. So now I do negative 5 times x plus 2, which becomes negative 5x minus 10, which we're going to subtract. The x's cancel. 6 minus negative 10 changes to addition, so it's 6 plus 10, which is 16. And the 16 is now our remainder. So our answer is x minus 5 plus 16 over x plus 2. For the synthetic division problem, I told you guys to make sure you accounted for the missing term, which a lot of you did, so yay. But we're still unsure of how the process of synthetic division works. So first is finding the number that goes in our box. So we take what we're dividing by, set it equal to 0, and solve. So in this case, x would equal negative 3. So we put negative 3 in the box. Then we put the coefficients of all of our terms across the top. So we have 3x cubed. There's no x squared term, so 0, 1x, and then our constant -3. The leading coefficient always gets brought down. So 3 is going to get brought down. Then I'm going to multiply it by the number in the box, which is -9. And with synthetic division, we add. So then it brings 0 plus -9 is -9. Then we multiply again. -9 times -3 is positive 27. 1 plus 27 is 28. And then 28 times -3 is -84. And -3 plus -84 is -87. So now the -87 is my remainder, 28 is my constant, -9 is my x term, and 3 is my x squared term. So my answer is 3x squared minus 9x plus 28 plus my remainder -87 over x plus 3. The last part of the quiz covered factoring. So there were 4 different types of factoring we covered, and the first one is factoring with a GCF. So let's do -25 a to the 5th b minus 30 a cubed b to the 4th. When factoring a GCF stands for greatest common factor. Anytime both of the coefficients are negative, our GCF is going to contain a negative number. So I'm looking for a negative number that goes into 25 and 30, which is -5. Then we look to see what the most amount of variables they have in common. And you can never factor out more variables than what the lowest exponent is. So if I look, a to the 5th and a cubed, I can't take out more than 3 a's because that's all the second term has. So a cubed. And then we have a b to the and a b to the 4th. So I can only take out one b because that's the smaller of the two. Then in the parentheses, we divide by our GCF to figure out what remains. So -25 divided by -5 is a positive 5. We took out 3 a's, which means we have 2 remaining, and there was only one b and we took it out. So that's all that's left of our first term. Because we factored out a negative number, this is going to change to a plus sign. This is probably the biggest mistake on the quiz, is because we factored out a negative, our operation needs to change to addition. Because -30 divided by -5 is a positive 6. And then there were 3 a's, and we took all of them out. And then we took out one b, which means we're left with 3 in the parentheses. Next, we were factoring polynomials where a is 1. So that's the leading coefficient. So something like x squared plus 11x plus 10. So remember, a method like this, we're looking for the numbers that multiply to our constant, which is 10, and add to the number in front of x, which is 11. So if I start thinking of numbers that multiply to 10, I first think of 5 and 2. But 5 and 2 don't add to 11, they add to 7. The only other way to multiply to 10 is 10 and 1, and 10 plus 1 is 11, so it factors as x plus 10, x plus 1. Next, we discussed factoring when a is greater than 1. For example, 3x squared plus 8x plus 5. Anytime a was greater than 1, I told you guys to always check for a GCF. And there isn't a GCF here because there is no number that goes into 3, 8, and 5. So I'm going to have to use the box method here. So my squared term goes in the top left, 3x squared. My constant goes in the bottom right. Now typically, if we tried to use the method that we did before, there are no numbers that multiply to 5 and add to 8. So what I want to do here is A times C. So 3 times 5, which is 15. So now I'm looking for the multiples of 15 that add to 8. And thankful for us, those are the numbers I multiplied together, 5 and 3. So I'm going to put a 5x and a 3x in my box. And it doesn't matter which box I put the 5x and the 3x, as long as they go in my remaining 2 spaces. Next, I'm going to factor out GCFs from each row and column. So I look for what do 3x squared and 5x have in common, which is just an x. Next, we look at 3x and 5. And there isn't anything, so we always just factor out a 1. And in this case, it's going to be positive. Okay. Now, when I'm going down, 3x squared and 3x have a 3x in common, and 5x and 5 have a positive 5 in common. So now the row going across the top is one of my factors, 3x plus 5, and the column going down is my other factor, x plus 1. So the last 2 things we covered were our special case polynomials. So difference of squares and then sum and difference of cubes. So difference of squares, something like 81x squared minus 25. So when we factor a difference of squares, we look for the term that when you multiply it by itself gives you your term. So what times itself is 81x squared? And that's 9x and 9x. And then we look for what times itself is 25, which is 5 and 5. So when you factor it, it's the same thing in both sets of parentheses, but one's a plus and one's a minus. So we have 9x plus 5 and 9x minus 5. And then our sum difference of cubes. So x cubed plus 125. So this time we're looking for the number when you multiply it by itself gives you each term. So x cubed is easy because that's just x cubed. 125 in this case is going to be 5 cubed. So the first set of parentheses for a sum of cubes is the addition of your roots. So x plus 5. Okay. Second set of parentheses always starts by squaring the first factor. So x squared is x squared. Then we subtract the multiplication of our 2 terms. So x times 5 is 5x. And then we add the square of the second root. So 5 squared is 25. The only difference between the sum and the difference of cubes is the operation in the first set of parentheses and that first operation between our squared and our x. So if, for example, we'd had x cubed minus 125, the only difference, it would have been x minus 5 and then x squared plus 5x plus 25. So the only difference is the operation inside the first set of parentheses and that first operation in the second set of parentheses. Other than that, the method that we write it in factored form is the same for both. Let me know if there's still something from the quiz you are struggling with so that I can make sure you understand it before the test.